Hey everyone, welcome to today's Explainer. I've got to tell you, I am incredibly excited about this one. We're going to untangle the incredibly complex, sometimes kind of messy, but absolutely fascinating web of our ancient human relatives. If you've ever found yourself wondering exactly how we got here and, who else was walking the earth along the way, well, you're in exactly the right place.
So let me ask you something. Do you know how many different human relatives actually used to share the Earth? Most of us probably grew up seeing that classic image of human evolution, right? You know the one, a single straight line of apes slowly standing upright and eventually turning into us. Well, scratch that, because that image is completely wrong. Human evolution wasn't some neat straight line at all. It was actually this wildly diverse family tree with tons of different branches. And at various points in history, multiple different human species were coexisting. They literally shared the exact same planet.
All right, so here's our roadmap for climbing the branches of our family tree today. We'll start with first steps on two legs, then look at the tool and fire innovators, explore some specialized and unexpected branches, meet the global Ice Age cousins, and finally wrap up with the dawn of modern human culture.
Let's dive right into Chapter 1, First Steps on Two Legs, the Earliest Ancestors. We're going way, way back to the very beginning here, millions of years ago, to a time when our earliest ancestors first began to stand up and literally view the world from an entirely new perspective. Just thinking about this timeline really puts the massive, almost mind-boggling scale of human history into focus. We aren't just talking about a few thousand years. We're talking about millions. 7 million years ago, a relative known as Sahelanthropus lived in Central Africa. Fast forward a good bit, and around 4 million years ago, you've got Ardipithecus navigating the eastern African woodlands. And then, by 3 million years ago, Australopithecus was making these daily treks back and forth between dense forests and open grassy areas.
Let's zoom in on Sahelanthropus for a second. Living a staggering 7 million years ago near ancient desert regions, they are a fascinating puzzle for us. They had chimp-sized brains, really thick brow ridges, and very ape-like features. But here's the kicker. The position of their skull actually suggests they might have had the ability to walk upright. Now, I say might because, honestly, very few fossils even exist for Sahelanthropus. It makes researching them incredibly tricky, and that possible upright posture is still a crucial yet hotly debated detail among scientists today.
And this whole debate brilliantly illustrates what evolution actually looks like in action. It's never an overnight change. Both Ardipithecus and Australopithecus were in this perfectly balanced transitional phase. Check out their climbing adaptations. Ardipithecus still had grasping toes, perfect for moving safely through the trees, and Australopithecus kept those long arms for quick escapes from predators. But at the exact same time, look at their walking adaptations. Ardipithecus developed hips that completely supported upright movement, and Australopithecus evolved legs built specifically for traveling across wide-open ground. They literally had the best of both worlds. In fact, one famously discovered Australopithecus fossil, known worldwide as Lucy, showed absolutely undeniable evidence of this upright walking.
Okay, moving right along to Chapter 2, the tool and fire innovators. A leap forward. Think about this. Once our ancestors were standing upright, their hands were finally free. And man, did that lead to an absolute leap forward in brain size and technological innovation. Just look at the incredible jump in brain size between Australopithecus and Homo habilis, which happened around 2.4 million years ago. As their brains grew larger, their hands allowed for much better grip and object control. Homo habilis, whose name literally translates to handyman, started using these sharp stone tools. They'd use simple but highly effective stones to quickly cut meat off large carcasses and even crack open animal bones. I mean, this was a total game changer for survival and marks a massive shift in our human development.
Now, the survival skills Homo habilis figured out actually paved the way for one of the longest surviving relatives on our entire family tree, Homo erectus. Appearing nearly 2 million years ago, these guys mastered 3 absolutely massive steps. First up, long-distance travel. Their long legs allowed them to migrate super efficiently, literally walking from Africa all the way to Asia and Europe. Second, and this is probably the biggest one, they figured out how to control fire. That meant warmth, nighttime protection from hungry predators, and cooking their food, which makes it way easier to digest. And third, they developed advanced teamwork and planning strategies for hunting. They were just incredibly adaptable.
All right, let's turn to Chapter 3, Specialized and Unexpected Branches, Unique Evolutionary Adaptations.
Now, evolution doesn't always march in one straightforward upward direction. Sometimes it takes a left turn into highly specialized, unique, and occasionally doomed adaptations. Our cousins were wildly diverse. Take Paranthropus, for example.
Living over in Africa, they adapted to eat super hard plants and rough roots by developing massive jaws and thick, gorilla-like chewing muscles. Then you have Homo floresiensis. Because they were totally isolated on a remote Indonesian island with limited food sources, they evolved to be just 3 feet tall. Scientists affectionately nicknamed them the Hobbit. They even shared their island with giant storks and tiny little elephants, which is just wild to think about. And finally, there's the really mysterious Homo naledi. These guys were navigating incredibly difficult, deep cave passages in South Africa to intentionally place their dead, despite having very, very small brains.
I actually want to pause on this for a second, specifically regarding Homo naledi. This quote hits the nail on the head. Their discovery challenged assumptions about intelligence and brain size directly. For the longest time, we just assumed that small brains automatically meant completely basic animalistic behavior. But Homo naledi threw a massive wrench in that. They showed us that a small-brained relative could still exhibit incredibly complex, almost ritualistic social behaviors, like organizing the intentional burial of their dead in deep, pitch-black cave systems. It is truly, absolutely mind-blowing.
That brings us to Chapter 4, the Global Ice Age Cousins, Surviving the Cold.
While some branches of the family got specialized for island life or tough root diets, others had to adapt to some of the absolute most brutal climates in Earth's history. The really crucial point here is just how perfectly these cousins adapted to their environments. Let's look at Homo heidelbergensis from about 700,000 years ago. They had these strong, sturdy bodies for active hunting, and they crafted perfectly balanced wooden spears that functioned exactly like modern javelins. They even built simple outdoor shelters. Basically, they set the stage for the Neanderthals who absolutely thrived during the freezing ice age. Neanderthals evolved short, robust bodies specifically to retain heat, and they had these large noses designed to warm up freezing air before it ever hit their lungs. They were making cave fires, stitching together animal hide clothing, and wonderfully, the fossil record shows they actively cared for their injured and buried their dead with real intention.
But that brings up a really fascinating question. If complete fossils are so incredibly rare, how on earth do we know about ancient cousins that left behind almost no bones at all? What if all we find is a tiny piece of a pinky finger or a single tooth?
While the answer to that mystery is ancient DNA technology, this is, without a doubt, a revolutionary scientific advancement. By carefully extracting genetic material from tiny, seemingly insignificant ancient fossil fragments, researchers can literally identify completely unknown species. We don't even need a full skeleton anymore. We can just read their genetic code and trace exactly how they connect to modern human populations walking around today.
And that exact technology is how we discovered the Denisovans. They are easily one of our least understood relatives, mostly because we basically just have fragments found in caves in Siberia and Tibet. But man, their DNA tells an incredible story. It turns out they were closely related to Neanderthals, and they featured unusually large teeth. But here is the absolute coolest part. Modern Pacific Islanders still carry Denisovan genes today. In fact, Denisovan DNA is actively helping some modern humans adapt to living in high mountain environments, like the Himalayas, right this very second.
And that brings us to a pretty beautiful realization. These ancient cousins didn't just vanish without a trace. Extensive interbreeding occurred after modern humans entered Europe and Asia. And because of that, you, me, and billions of other people alive today still carry Neanderthal and Denisovan DNA. They didn't really disappear. They literally live on within our own genetics.
Which leads us to our final chapter, Dawn of Modern Human Culture, the Cro-Magnons.
Now we are stepping right into the dawn of modern human culture, looking specifically at early modern humans in prehistoric Europe. With the Cro-Magnons, whose bodies looked almost exactly identical to ours today, we see an absolute cultural explosion. We aren't just talking about raw survival anymore. We are talking about art, community, and society. They were making highly advanced tools out of stone, bone, and antler. They observed the world around them and painted vivid, incredibly detailed hunting scenes deep inside caves. They even created delicate jewelry from shells and animal teeth, and wore carefully designed, perfectly fitted clothing. But most importantly, they shared stories, passed down traditions, and coordinated highly planned hunting techniques through advanced communication.
40,000. Roughly 40,000 years ago, a massive, unexplainable shift happened. For reasons scientists are honestly still trying to figure out today, the Neanderthals disappeared entirely from the landscape. The Cro-Magnons, however, managed to survive those harsh ice age conditions across Europe. They thrived, they expanded, and they connect directly in an unbroken chain to the modern human populations we see today.
Which leaves us with this final, really thrilling thought. If we've discovered hobbits on remote islands and managed to identify entire species like the Denisovans from the DNA hidden in a single pinky bone, what on earth will future fossil discoveries or advanced DNA technology reveal next? Just how many more hidden branches of our family tree are out there, waiting in the dirt, or even hidden deep within our own genetic code? Keep your eyes on the science, folks, because our family history is definitely still being written. Thanks so much for joining me on this explainer, and keep learning.